Here we go. This is going to be hard on the eyes to do this back and forth. 2 down. It is gently sloping area in front of a receding glacier. Okay, so in front of a receding glacier, where thousands of streams stratify, so layer, remember? We said stratify, or stratified means layered. Fine glacial till. It's worth our highlighting the word till, okay? So fine glacial till. Where are we going to find 2D? And the answer is on the features side of the page of the reading. Many other landforms form glaciers. The most important is the outwash plain, gently sloping area in front of a melting glacier. Okay, so we want the up here outwash plain. Okay, leaves all kinds of finely stratified till. Okay, makes the soil fertile. Now, under all the weight, a glacier becomes rather something, allowing it to move. All right, well, back to how glaciers work to begin with. When the snowfall reaches a thickness of 100 meters, that's pretty weighty, the ice at the bottom becomes plastic-like and begins to move slowly. So, question 3 down. Here we go. Question 3 down is going to be plastic-like. Like the surface of ice after a Zamboni has gone over it before you begin skating. All right, number 4. How thick in meters was the giant glacier that once covered North America and Eurasia? Well, basic descriptions, basic features. 4D, 4 down. The Laurentide, that covered all of Canada and some of the northern portion of the United States, as well as Eurasia. Enormous glacier reached a thickness of 3,000 meters, 3 kilometers thick. Can you imagine ice 3 kilometers thick? Okay, so what did we need to fill in here? We needed 3,000. There we go, 3,000. Good. 6 down, the American Midwest and Canadian prairies owes some of its something to relatively recent glacier deposit. Okay, and Midwestern part of the United States, right at the bottom, owes some of its soil fertility to outwash glacial deposit from the last glacial, or the latest glacial age. So, 6 down, we need soil fertility. Soil fertility. There we go. Soil fertility. Good. Number 7. Despite its huge weight, a glacier can move an actual full something a day. Listen, this is the difference between when I originally wrote this and how I updated it. The original puzzle, which I didn't feel needed to be redone for 2 boo-boos on here. The original puzzle and the original reading, it was a meter, but I actually, in my own research over the years, found out glaciers, of course, can move as much as 30 meters per day, as recorded in Greenland, and I think you'll find that that's a recent phenomenon with global warming. So the truth is, it can move much more than a meter, but the majority of them don't move more than about a meter, either forwards or backwards. Let's just stick with a meter, because this is really what we're looking at for the average. This is out of the ordinary, unless, of course, the planet gets a hell of a lot warmer, as it seems to be doing. All right. Number 8, also a mistake, just write in huge rivers. The original reading had it in, then when I redid the reading, I took out that information. Don't worry about it. Huge rivers, I'll tell you what, huge rivers are left behind, okay? Or they can carve, left behind, and they carve landscape. This is from the meltwaters. Right? So the mighty Mississippi, I don't know if you remember in the video, they talked about it changing its course. Well, it carved a new course. Huge amount of flood water. Going over Niagara Falls, huge amount of water. There's a number of occasions in which this has occurred, and it's gouged the landscape. And then sometimes the water diverts, it disappears, and we're left with this bizarre thing, this valley that's been carved out, and it was all from the glacial meltwaters. Anyways, here we go. Number 11. During what ecological epoch did the glaciers recently cover this continent? So when was the last time, or the latest time? And the answer for number 11 is right up top here. Here we go. Glaciers covered a large part of the Earth's land as recently as 8,000 to 15,000 years ago during the Pleistocene epoch. Okay, we live in the Holocene, but we're looking at the Pleistocene. So whenever you watch those Ice Age movies and the saber-toothed tiger and mammoth, that was the Pleistocene. Okay, is when that occurred, when those stories would have occurred. All right, last couple of questions. Sorry, did you get Pleistocene? Pleistocene. There we are. What are lakes left called that are left in a circle, in a cirque, another French word, right? Hey, let's get that one highlight too. In a cirque, once the glacier is fully gone, we're going to find that feature up here. Tarn lakes form in a bowl-like cirque, and bowl-like cirques carved in the upper reaches and mountainsides. Here, these are cirques, but when they're in a chain, bing, 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 they're called paternoster lakes. That's Latin for our Father. And the reason why is for Catholic people, and in Italy and in France and in Switzerland, you're going to have a lot of Catholic people. And Catholics have these things called rosary beads. And rosary beads, the idea with them is each bead, you would sort of thumb your way across them and you would say a prayer. At the bottom of it, of course, you'd have this cross. Anyways, for each one, you'd have a prayer, and the prayers would either be an Our Father prayer, in any case. So people looked at them a long time ago, and they went, oh, they're like the beads on a rosary. They're Our Father lakes, okay? So let's just, down here, a string equals paternoster lakes, okay? A string of these tarn lakes. But let's get back up here and write in the word tarn. Okay, getting close to the end here. What does the shear weight of glacier do to rock below as it moves it? 15D, the weight of the glacier breaks up underlying rock through plucking and abrasion, the scraping action back and forth. So we're looking to fill in breaks up. We got one left. Our one left is the basic term for glacial moraine, left behind by a glacier as it recedes. We've actually already got that word here. We've highlighted on here already, till. If you were looking for it here, it shows up in a couple of places. Glaciers create landforms that have been deposited debris, called glacial till, consist of rocks, pebbles, silt. Glacier melts, leaves behind hills of glacial till called moraine. So our final answer is till. Now, couple things also we want to highlight on this diagram, okay? One, the cirque. This is the bowl shape that occurs there, cirque as in circle, okay? A horn. This is the most famous one, okay? The most famous one is the Matterhorn in Switzerland, okay? The Matterhorn. It's a bit like the arête, but it's like carved on all sides around. Okay, and we also wanted to identify this outwash, okay, the outwash plain, okay, where all that glacial till, that fine till comes out and adds to the soil fertility. Now let's go back up here and let's remind ourselves of a couple of these things, maybe highlight outwash plain. Well, yours isn't in red and it shouldn't bleed. Anyways, let's highlight U-shaped valley because that one's important. Let's remember the fjord. Arête, there it is again. It's in our diagram and it's here too. We're going to remember the lateral moraine on the side. The Tarn Lake. Okay, so this will, cirque will turn into a Tarn Lake down the road, maybe. We assume. And then, of course, this other fancy word, till. It's not that these other words aren't important, it's just these are all features, right? Features that come from glaciation. I'm going to pop up some pictures for you to go along with this. In particular, what I want to do is pop up some pictures of some features that get left behind. Eskers, drumlins, all right? And check out and see what else I've posted up there. There's some other features that I'd sure like you to possibly familiarize yourself with, and as well as the next work activity. Okay, that's it for the Take Up video. Thanks so much for watching.